tell you, am I a moron? I figured you guys didn't want to be on YouTube. Maybe you do. Okay, so let's go over number 1 on thermal worksheet number 2. We're reacting barium chloride with sodium sulfate. So you have to you have to remember how to write formulas and how to balance reactions. So with barium chloride, barium's a +2. How do I know that? Because it's in the second column. Chlorine's -1, crisscross barium chloride. Plus sodium sulfate. Sodium's a 1+, sulfate's a -3. No, 2. How do I know it's a -2? Because it's in the same column as sulfur, which is sulfur's a -2. Otherwise, you can look it up. Crisscross, there you go. What type of reaction do we have going on here, Anna? Double displacement. So I'm going to switch the sodium and the barium. Rebalance. Okay, we're balanced. Now I balanced my whole equation. I'm going to need a 2 there. And I'm good. Now let's find, they don't give you a whole lot of information. I wish they would have done a little bit better, but this is aqueous, this is solid, this is solid, and sodium chloride is solid as well. So the first thing we have to do is find the delta H of the whole reaction. Is it positive or is it negative? So we get out our delta H formations. We get that from Appendix N. So barium chloride is -872 kilojoules per mole. Sodium sulfate is -1387 kilojoules per mole. Sodium chloride is -411 kilojoules per mole. And barium sulfate is -1473 kilojoules per mole. Now we do the products minus the reactants. Here are our products. So -411 kilojoules per mole. We multiply it by 2, because there are 2 moles of sodium chloride. And we add the other product, which is -1473. Then we subtract the reactants. -872 times 1. Add the other reactant, -1387 times 1. And our delta H of reaction. negative 36 kilojoules. And then that's per mole of 1 mole of barium chloride. That's per 1 mole of sodium sulfate. That's per 2 moles of sodium chloride. And that's per 1 mole of barium sulfate. Now they wanted to know how much is released when we do 20.8 grams of barium chloride. So for the barium chloride, I start with what is given. If I have grams on top, I get grams on the bottom. Convert it to moles. Barium weighs 130. Man, stupid allergies. 137. Chloride is 35.5 times 2 of them. So that's 208 grams, 1 mole. And then we're going to use this ratio because we're dealing with barium chloride. For every 1 mole of barium chloride, we have negative 36 kilojoules. So now when I multiply that out, I get, I don't know how I have 3 figs there, but anyhow, I got negative 3.6 kilojoules. The paper says negative 3.65, but I'm not sure how you end up with 3 figs. Oh, I know, because I probably went out to a decimal point. Any questions on number 1? Can I erase it?
Go for it.
Okay, so now we're going to do number 2. Number 2, we're decomposing cobalt plus 2 carbonate, CO3 with a minus 2. So that's cobalt carbonate. That's balanced. And it's decomposing into cobalt 2 oxide. That's balanced. And carbon dioxide gas. Okay, so let's see. Is this thing balanced? Yeah, it is. That makes it nice. We on a font. Oh, and they even tell us. Oh, they tell us the delta H formation. I thought they told us the reaction. So, sure.
It's 9 minutes.
9 minutes?
Yeah.
Oh, we got time. So, the delta H formation of cobalt carbonate is negative 723. For carbon dioxide, gas, I should really be putting what these things are. Carbon dioxide gas is negative 394. Cobalt oxide solid is negative 238. So we do our products minus reactants. Subtract our reactant. And is 91 kilojoules per mole. And they want to find out how much heat is released by 17 grams of cobalt carbonate. So we start with our cobalt carbonate. To get into moles, we get the molar mass from the periodic table. Cobalt weighs 58.9, carbon weighs 12, oxygen weighs 16, and there's 3 of them. So this weighs 118.9 grams. And then for every 1 mole of cobalt carbonate, I'm going to need that much heat. So for every 1 mole cobalt carbonate, I will need 91 kilojoules of energy. So my answer, which is pretty darn close to the page, 13.0 kilojoules of energy are needed to start the reaction.